Alright, here we are at our dot plot that we made last time at the end of the first video for Project 1. And if you want to remember that this was set at length 27, identity 78%, and it did not have the inverted repeats. And I want to show you something on the inverted repeats real quick if we run it. So here's the piece that we're going to investigate here in this video. We're going to start with these, and we're going to extract our sequences from the two sequences and run them on here in just a second. But I want to show you something that you can do. So if I go to parameters and now I search for inverted repeats and I add that on here, which I normally do, notice that we get this, but when we get this going over here, that's the same, and these are the same. And the indication here is, what this means is this gene has been, pieces of it have been duplicated in the nearby sequence. In other words, somewhere in replication, usually when the cell divides, at some point the DNA has been duplicated, and it's repeated, often inverted, along the strand, and it's been done several times. And this can explain perhaps why we have so many GPXs. Now there's also something called crossing over, where pieces of DNA get transferred to another chromosome. If this were to occur and then transferred to another chromosome, it's a good chance that you will get a duplicated gene, just as we see with GPX 1 through 8. You see them on different chromosomes. So there is an explanation for this, but I would like you to also turn on the inverted repeats and indicate if you see something like this indicating duplication, and you probably should. And it is along the pieces. If you'll notice here, it's at the pieces that one way or the other, either on one strand or the other. So here these are duplicated and these are duplicated. It's duplicated in both genes, and this is probably the piece that has the functional part, and I suspect this is way outside the gene over here. This one may or may not be outside the actual mRNA, I don't know, but this is the piece we're looking at, and this is the piece that shows up when you don't put in the inverted repeats. So this is the piece we are interested in. Okay, there are some other little pieces here, but this is the piece we care about. All right, let's see. What else do we want to look at? We need to look at this sequence. All right, so I'm going to use my scroll. I'm going to put the scroll around it. Let's see if I can do that. Click on it and once you click on it and get a red piece to show, then you can put a box around it, and you can scroll to that box. You didn't know how to do that, so you click on it, get a piece of it to highlight in red, and then scroll, click and create you're gonna do a cut and paste or something around it, and then you can use the scroll bar. The scroll on your mouse, and you can zoom in, which is what I've done here. So let's see. I want to get it all on there. That should be good. So let's start with this piece, and let's see. This is we need to get these pieces on both of them. So I'm going to say, let's see. This is coordinates on X and Y, so these will be the coordinates on each gene. So the coordinates for 1 on X, so we need to record this, so we need to bring up our notes. All right, and we should probably record, okay, dot plot parameters. All right, and we should record that, which they were length equals colon here, And these are just things to put in your notes, so to go back and put into your paper when you're doing it. Length is 27. And let's see what our identity is 78%. This keyboard, okay. 78%, and it's for these two. You might go, I know which ones we're doing. We're doing this one and this one. So in that region, okay, so the region of interest, okay, and so we'll do it, and we'll do it here, and we'll look at it from X and Y. So when I do this, it says the X region, which is the one across the top or bottom, is at 4578. So we need to record that. 4578. Two. All right. Now that other number is not the 2. That's going to be the Y. We need to figure out which one is 4578, and that one is our longer sequence, I believe. Yes. So the one that is much longer, and that one, let's go back and make sure we know which one that is. Here's one. Alright, that looks pretty long, but which one's the longest? This is, let's see. Now that was the Homo sapiens. This is the other one. So the first one, the long one is GPX8. The short one is GPX1. All right. So GPX1 is the short one. So that would be GPX8 then. Here, let me close that. Open our other. Oh, did I close it? Oh, it looks like I did. No, I didn't. Here it is. All right. This is going to be GPX8. So GPX8 and 2. Well, let's go ahead and do GPX1 since we're clicked on this. All right, so we're starting here. When I click on that, 4578 to, oh, come on, it's hard to get this to pop up, 2448. All right, so let's put that down. 2448 to, all right, now we're going to go to the end of this length here, this piece, and I'm going to get that little pop-up here to come up again. Oh, come on. It is hard to convince it to do it. There we go. 4745. Oh, write it down. 4745 and 2613. All right, so I'm going to write that down. So it's 4578 to 4745. All right, and it is to 2613. Okay, now these are the two sequence. This is your region of interest. All right, I'll cluster this together. All right, between GPX1 and GPX8. These are pieces that we want to grab out of our sequence and look at. So here's where we can go and use my program. Okay, so I've got 2 Eugenes on right now. Let me close one. I'll close both of them. We don't need Eugene for a while. Okay, so now that we have those, I am going to go to my program. You can go to whatever you have to work with, and I am going to open local file. And the one I'm going to open, let's start with, let's see, I put this where? Desktop. And I put it in our class, Spring 25 FIFO, Project 1. And here are two. So let's do the long one, which is GPX8. We'll do that one first here. GPX8. Alright. Now here you might want to record this. Oh, you don't get this, sorry. Never mind. I will show you this in a little bit, but since you don't have it quite as easy, you can get it on bioinformatics.org. You can put the sequence in, but you can get the GC content, so that's G plus C. Alright, so this is for GPX8, and for this whole sequence that we collected, which remember, it has pieces before it and after it, is 39, about, we'll just say 39.9%, I rounded up, G plus C. Alright, so it's actually low GC. If they were ATGC equal, it would be 50%, and it's lower. And then we want the CPG. Alright, we want the CPG content, and that is 0.018%. Or let's see, yeah, 0.01, no, that's 1%, 1.8%. 1.8% there. So realize that is that's rather low, and both of them are really low. I'm not going to explain entropy here, but entropy tells you how much information is in there, and if it equaled to 1 there, it's equal to negative 97.97, but equal, if it were, the negative doesn't matter. But if it were equal to 1, it would have as much information as possibly can be within the sequence. And this is like 97%. There's a gene here. This is what I'm saying. This is not a random sequence. In other words, this is telling us that this sequence is not random. And so there are many forces working on it to make sure that it is not random. And a 1, ignore the negative, a 1 would indicate non-randomness, or full of information, put it that way. Alright, so we've looked at it, we've got it here. We know that GC, you can take it and put it into the other one, but really, what we want is, we really want to get that piece, we want to extract it and make a new, we want to make a new FASTA with just that piece, that the two pieces that were of interest in GPX1 and GPX8. That means we want, what was it? What we wrote down, that's why we wrote it down. We want, in GPX8, 4578 to 4745. So, let's put this down here. So let's look for 4578. So I'm looking, notice I'm looking here as I move this. So I'm looking for 4578. That's going to be down here somewhere. 45, 45, 44, 45, 42, 45, 59. So it's going to be back this way, 45, 78, 45, 75, close enough I think, and we want it to go to, so we want this, and that's 49, so that's too far, so 49, we don't have to be exact here, we just want the piece that in general. So let's see. Let's bold this region, or underline that region. We want to start here. All right, somewhere in that region, and we want to go to 47.95. Oh, 47.45. Somewhere right here. Alright. So right here is 45.79, and this is 47.45. Okay, it's not that long. It's still 200, what, roughly 200 bases, or is that right? I saw. 150, 160, so 150, yeah, about 160 bases. All right, and this is the area, so I'm going to grab that. So I've highlighted it. I'm going to go Control C, and I'm going to put that in our sheet, actually, our document. That's small enough to go in there. So this is roughly, it's not the exact sequence, it's around that area. So you don't have to be that accurate. We're just looking at, oh, it doesn't control, doesn't, did I hit it wrong? Control C. Alright, I come here, Control V, there we go. And we have our sequence, so we can analyze it later. Let's go find the other one, the 2448. 2448 to 2613. Now let's go find this one in the other sequence. I'm just going to close it. Alright, and I'll restart just because I don't trust this version for that. And so we've got to find desktop again. Project 1. And now we're going to do GPX1. And here we go. And I'm going to record that GPX1 is GC is, well, 55.6% GC, so a little bit more, and the CPG is 8.8%. All right. In other words, GPX1 is considerably higher GC content for the entire sequence, anyhow. That might be because we have a lot of non-coding sequence probably in the 8. We might have taken a lot more sequence outside, or maybe the introns are very large or something in GPX 8. We'll investigate that. All right, that's one thing we're going to investigate. So let's get our new sequence here. Here we have this one, and we're looking for 2448. We'll come back to the GC content in a little. So we're looking for 20. Wait, how big is this? 35. Okay. So 24, it's towards the end. Did we make a mistake and not put 1,000 on the right side? We might have. This is actually the part that's common is outside what we thought was the coding sequence, but this is what we found. So we will record this regardless. So 24. No, I guess it's probably it's just at the end maybe. 2448. 2456, so it's somewhere in here. 2448. Right here, that's close enough. grab that. I'm going to underline that so we know where it is. We're going to go to 2613. So 2613. It's going to be down on this end. 2620. There we go. Somewhere in here. Okay. So between these two underlined pieces, let's grab it. Alright, I'm going to go Control C. And I'm going to come back to our paste. I'm going to paste this in here. Alright, so now we have some data to work with. This is the piece that is common to both of them, and we need to compare them. So here's we're going to do this in class this coming week. We're going to look at some of these programs, but we're going to look at them now, and we're also going to search for these in BLAST. So this has a lot to do. This is what we're going to be doing this week on Wednesday in class, doing some of the things we're going to do right here. So we have our sequences that we want to look at. So let me close this. We aren't going to need this again, I don't think. And what I want to do is I want to take our two sequences where they have it in common, and I do want to open Eugene again. Open. All right. And just to confirm everything, let's well, you know what, let's first make FASTAs. So we have our two sequences here. Alright, and let's turn these into FASTA files, but let's not do it the way we've been. Yeah, I guess we do have to make two. So let's make a new FASTA file, and so that's greater than sign, and we'll go GPX8. I'm just going to common region with GPX1. Alright, and that's going to be this sequence right here. So I'm going to grab that. I'm going to go Control C. Go back to our document here, Control V, and if you want to splice it into 70s, feel free. Let's see, where am I? I am at column 83 right there. I'm looking down here, if you look down here on mine. So that's 70 right there. So that means that's 70. So to make it, I can just do this right there, and that would be with the correct format for our project. So here I'm going to go Save As, and I'm going to go Desktop. Where did I put it? Right here. Project 1, and we will call this GPX8. Common with GPX1. Okay, .FASTA. And I'll save that in there. Now we'll also we'll make a new one, and we will call this one GPX1 common region, whatever you want to say, with GPX8. Alright, so the first one is the one that we're actually drawing from. Let's see here. We need this. You have to keep track of which one you are using. Copy. Control B. be. Alright, let's scroll back to the beginning here. And let's find about 70. Column 46. Column 70. I'm really good at picking that out. Alright, file. Save as. And this one, it's going to be, and we're going to switch the numbers around. This one's going to be 1 with 8. And save. Alright, so we have our 2. Well, I probably shouldn't have closed that, but oh well. Now we want them just to, for fun, let's look at them. So let's go with, let's see, where are they? Common, I'll go with 8 on 1 first. So this is this one, just ever so slightly larger. And this one here. And then we'll go next. Might as well search for inverted repeats, at least initially. Click here, and let's just see what we get. Oh, kind of interesting. Lots of stuff going on here. Let's undo that. Parameters, let's take the inverted repeats out. You can see it's not real consistent through this region, but it's there. Alright, we got lots of little low, maybe some regions where the letters are the same. I mean, like a bunch of A's or AT's, a repeat of some sort right here. That's probably what this is. Let's see. Let's change our parameters. And we want to increase. I'm going to go to 12. We'll see if there are any places where it's 12 all in a row. Yes, right in the middle. Alright. And then once we've got 12, let's reduce it. So let's go to 90. Let's see how that changes. Alright, and we add a little. And then we go to 80. And that's looking good. We aren't adding much stuff on the side. We're just completing our sequence here, which is great. That's what we want. And let's go to 70 and see if now that's when we add some stuff on the side. So let's go back and let's go back and let's go to 75. That's not enough. So let's go to 78. That's enough. Alright, so 78 gets us a pretty good clear picture of what is similar and what's not. That would be a picture that you want to save and hand in. Now, but that's not all we want to do here. Well, let's see if we can get it just a little bit better. You practice using let's see what happens when we put the inverted repeats in. Nothing. Alright. Alright, so let's take that back out. So we've got 78% on 12 bases. So let's lower that a little. Let's go down to 10 and see if we pick up a few. We do, but we get all of that. So I'm going to do that, and I want to go up to 80. Maybe this will be a little better, maybe not. Parameters, let's go up to, it's 10, so it's not going to make a difference till I get to 90. So 90. Now, I think where we had it was about as good as you're going to get. So I think that was at 12 and 78, I think it was. 12 and 78. Yep, that's as good as I think you're going to get it. So this would be a picture to turn in with it. That this is the homologous regions. We could. No, this is good enough. All right, so this would be something you want to save. So I'll just go ahead and go here to save image as, and we can save GPX1 comparison of GPX1 and 8. Actually, it's kind of making a name for us, so okay. But where is it putting it? Let's make sure we put it where we want it, which is documents. No, we want desktop. Project 1. And yeah, it's telling us what we're comparing there. It gave the whole name. So I like that. I like that it did that. And we will save. And it's exporting as a PNG. That's fine. You can also do it as a JPEG or a bitmap or TIFF. Maybe JPEG is a little bit more common. So there we go. All right. So we now have a picture to go with what we found. All right. So we have a picture. That's always good for your project to show the regions. Now the other thing we're going to do here, we're going to close out of dot plot. All right, and we're going to go back to these sequences. And what we want to do is we want to do an alignment. Now, I don't know if yours is configured like mine. You may not have all of the programs here on the side. If not, you'll have to go online and we will learn this in class. But you can have these programs already installed on your within Eugene. And here we've got ones I talked about: Muscle, Clustal W, Clustal Omega, and Coffee. I also have Maft and K-Align. I'm going to go with Align. I'm going to go with this one, Clustal. I always say this is little W. This is W, which is little Omega. So it's like big A, little A. So little A and big O. They're kind of that way. But I'm going to go with this one. And what we're going to do is we're going to put in our fast days. And so we have to go to, where is it? That was, here's where we are. And I want to go with the largest one first. So if I look at this, GPX1 has 204 bytes, and GPX8 common with it has 204. This one has 204. I want to go with the larger one first. So I'm going to take that one and I'm going to open it, and then I'm going to grab this one and oh, nope, it won't do it that way. I forgot. Okay, it needs you to do something different. Alright, so for this to work, we have to create another file. And we're going to create it. It's a FASTA. So I'm going to create a new document. It's going to be an empty document. And it's going to be a dual FASTA. We haven't made one of these, but this is going to have both of our FASTAs in it. GPX 8, and I'm just going to say and GPX1. Okay, so not common. Both of these, well, I'll say common parts. Okay, it isn't real explanative. You'll see after I do it what I'm doing. Oops. Alright, FASTA. Alright, so I've created it. Common parts versus common with in the middle. Now I'm going to open this. It's blank. Alright, and what I'm going to do is I'm going to open our other common widths. Alright, this is GPX8, and I'm just going to literally copy it right here, and I'm going to put that one in there first. Alright, I'm going to put a space. I won't even put a space. You don't need to. And then you go do the other common with, which is this one. Alright, and you grab it. Control C. And you can just literally Control V. So we have 2 FASTAs in one file, but that's fine. This program will read those. So we save that. Alright, and actually I'll just close it. And that file right here is the one we want. Nope, it's this one. It's common. Let's make sure it's there. Yes. And I misnamed it. I said GPX9, so let's rename that. I misnamed it. That should be 8. There we go. Well, I think we get it. Common. Oh well. I really messed up that name. I hit some key. I hit the home key. Oh, it doesn't matter. I know what it is. That's the one we want to load into Coffee, or whichever one. We were doing Cluster Omega. So you go down here to, where is it? Well, I just saw it. We were using it. Multiple sequence alignment. Alright, and we're going to go to Omega. And my input file is going to be that weird one. Well, maybe I didn't rename it. Oh, this one here. Common parts. And right here. Okay. And we open that. Now we have to put an output file. And this one you should make it an ALN. And so the name of this file, we're going to go GPX1 and GPX8 interest. And here's the difference. It's .ALN, an alignment file. Alright, and we'll do this. Alright, and we are going to save that. Alright, and then we're going to tell it to align it. Now, we don't know the number of iterations. We don't know anything. We're just going to, I'm going to let it run. There are some things, parameters you can set, because it does kind of use an early version of AI. If it were, it's not really AI, but it is a kind of a neural network type thing. Okay, so let's align it, and it shouldn't take too long. No, because it's a very small sequence, and it aligns them. The best possible alignment, at least given the limits to this program. And so it's showing you the places where it has common letters and the best combination. And of course, we're seeing what makes this a GPX gene. Now we really ought to have another one. In other words, what we're doing here is we're creating a consensus. It's consensus with just 2, and you can look up here wherever the bars are high. That's where it's aligned. Alright, and where it's not. So the most important pieces were in here, with all these T's. Here's a Gaga. Not that that has anything to do with anything. But these are the sequences that need to be that were in both of those GPXs, and probably had to do with the functional parts of a GPX gene. We don't know that until we get a third one. Third one will confirm that this is an important region. This is simply the most important region common between 1 and 8. So it might be some other chemical parameter that might not be in 8, maybe 1 and 5 would be a different region, and we're not going to get something like this. Don't know yet. All right, so this is what you need. Now we'll need to save this. All right, and you can save this as a picture as well. So you can right click just right here. All right, and let's see, we can. Well, I thought you could print or save it from here. Export, yes. Export as an image. Now, there are a couple of ways. Appearance, we probably want, well, let's just see what it looks like. But we will export as image. Alright, and we want the whole alignment. If we have more than 2, I would say include the consensus. It really doesn't make sense just 2. That doesn't include names. No. Bases per line. We'll just call this multiple alignment, and I'm going to call it 1.8 GPX 1.8. I know what that means. It's between GPX 1 and GPX 8. And we're going to save that. So we're going to export that. And I guess JPEG is probably slightly more common, so I'll choose JPEG and include a ruler. Oh, we can include this. And we'll make it 70 since we're kind of used to doing 70 with a fast A. Not that you have to do any of this. Alright, and boom. We now should have an image of this in our thing right here. There we go. Alright, and that might be an image you can put in your paper. Is this the best one? Absolutely not. I suspect that all it did was centered it. Now maybe that's the best one, but I bet that's not the best you could do. A human could probably look at it and do better, but let's, just for fun, I'm going to go ahead and do it with another one of the programs since we've got it all set up. Alright, why don't I go here to, let's go to coffee. I'm going to input our file again, and that is this one, our common GPX, GP, whatever, and I messed up the title. Alright, and we'll make the output file, we'll make it slightly different from this one. I'm going to put coffee in front of it. And we'll save as our output file. And now here we can put all kinds of parameters to change how this works, but I'm just going to align it and see if it does anything different than the other one. It did. Alright, I think this one is slightly superior. Alright, so let's go ahead and save this one. You know, I'm gonna ask you to do it with at least 3 of the programs there. That makes sense. So here we go. Because this is looking like you need to. Alright, so this is multiple alignment, and I'm going to put it 1.8, but I'm going to put coffee in front. And probably ought to go back and say the other one is Clustal Omega, Clustal O. So export. Okay. And let's see. Oh, here it is. Coffee. See what that looks like. There we go. Oh, kind of ugly, spread out like that. Maybe you can work on the format, but you'll notice that they moved over the thing. He put a couple of letters in and did it, and that might be legitimate. I don't know. Let's do one more just to see if we get something better with the others. Let's see if we can make that look a little better. Hold on, appearance. No. Maybe zoom in a little. Right click. Export. Oh, that's what we did. We made it so it's 70. That's fine. Now I made it larger. This one's going to look, well, this will probably look better. And we're going to replace that one. Let's change it to JPEG, I guess. That'll do it. That won't override it now. All right. Let's go see what that looks like. That's the PNG. This is the JPEG. Yeah, I like that. That looks pretty good. All right. Just notice that it's a little different than the other one. So these two. Now, I do want to do another one. Maybe we'll do MAFT or something. No, not MAFT. That's for whole genomes. Let's see what we have to work with here. I'll close this. And we'll go multiple alignment. Plus W. Let's do muscle. Alright, we'll grab that and we'll go to our right here, this one, coffee, GPX1 8, interest, output file, we're going to go muscle now. So instead of this, we're going to go up here and then we're going to take it and we're going to go muscle. Alright, and I'll save that. And let's see, muscle default. Full alignment, align, let's do that. And I think this one ended up looking like the first one. So it looks like that middle one, yeah, it just repeated what the first one did. So this one didn't do much different than the second one seemed to be, coffee seemed to be the best. It actually did something that would then just center it. So we can save this. Where is it? Export image. All right. We're going to call it muscle. Switch it to a JPEG, basis per, and we're going to make it 70. Export. Alright, and we'll go look to see what that looks like. There is muscle right here. Yeah, here we go. Yeah, it didn't do anything but the same as the cluster omega. Alright, see, 3 of them. Yeah, those are probably 3 best ones if you have those. If those are already installed in Eugene, go ahead and do all 3. We'll talk about it in class. But this should do it for our second video and what we're trying to do. So we got our our region that were of interest, and we aligned it and looked at it with a dot plot. And that should do it.